మ్యూట్ చేయాలి.
ఉంది.
పడేసింటే
Hi guys, yesterday we have seen how to prevent the thread execution. Before that, we saw all basics of the multi-threading. What is a thread? What is the life cycle of thread? And yesterday we have seen preventing the thread execution. Now today we can see some more topics of multi-threading, and we can close this multi-threading. Now here in multi-threading, we want to we are not going to use multi-threading in most of our programs, but we use multi-threading only in some few scenarios. Like if you have a task which you have to call the task has to take care of the execution of the program, but the task will give 200 OK response. For example, if you want to save the data into the database, I'm just calling the database, saving the data into the database, it will take 2 minutes of time. But what I have to do is, I just have to create a task, just execute a task. Task should give response as 200 OK. But in the background, we are creating a thread. Thread is called creating a call stack. The call stack will take care of executing the all steps, whatever is there in the thread class. So the thread will execute in background. Then we'll just notify the task. Task will take care of creating everything, but we'll come out and we'll give the response as 200. Okay. Only in that scenario, we used most of the time multi-threading. But we can take an example we'll explain today. But more on the multi-threading, mostly they will use in the banking projects. We have to learn what is the concept of multi-threading. That's it. Because in the interviews they'll ask, write a program for how to create a thread, how many ways we can create a thread, what is the life cycle of thread, and how to prevent the thread. We have to learn the methods, yield method and sleep method and join method. And now today we can see some more topics. That all topics also we have to learn for interview purpose. But in most of our projects, we won't use multi-threading mostly. In very rare scenarios, we can use multi-threading. Let's go and see today topics. Now I have program one. Inside program one, I have a class util class. What the util class will do is, see whatever common code. If you want to use any code commonly in different all other classes of your project, so you can keep all common code in one util class. The same util class we can use anywhere in our project. For example, I created util class. Inside util class, I want to print the numbers from 0 to 10. Just I am passing the attributes. From is the first attribute, 2 is the second attribute. From 0 to 10, if you want to print, just call print numbers method by passing 0, 10. And for which character we are printing the numbers. So I am passing the third character, third argument is a character. Now here, inside print number method, int I equal to 0. From is 0, int I equal to 0, I less than 2 is 10. From 0 to 10, I am printing the numbers. But here, inside system.out.println, C plus C is a character. Character plus value equal to I. So I have a print method which is printing the values from to 2. From is 0 to 10 or 10 to 20, 20 to 30. We can give any number from to 2. But it should be from should be less than the 2. Now this is a common function which I want to use in the 3 thread classes. I created 3 thread classes, class E, class F and class G. Now class E extends thread. Inside run method of a thread class, I am calling util method. Util.print numbers from 1 to 5. It will print first value equal to 1, value equal to 2, 3, 4, 5. Then the character is E. The E value is 1, E value is 2, E value is 3, E value is 4, something like that. It will go up to the 2, 5. Now, whenever we call the class F extends thread, this is also one more thread. Inside class F, we have a run method because it is a thread class. So here util.print numbers from 5 to 10, and I'm passing the character as F. Now I want to see in every thread, the thread name I am passing as a third character, third argument of a print numbers method. So first number is from number, second number is to number in the for loop. In the class F, I am printing the numbers from 5 to 10. In class G, I am printing the numbers from 10 to 15. I have 3 classes. 3 classes are doing same task, printing the numbers. But the printing numbers is different from 1 to 5, 5 to 10, 10 to 15. If you want to change the number, if you want to print from 20 to 25, you can change here, 20 to 25. No need of changing this code. But basically, till now we have seen the same code. We are printing everywhere. The same code you have to copy everywhere, wherever util.print numbers is here. But in the Java, if you have any duplicate code, just remove the duplicate code, make that code as a one function, util function. Use that function anywhere in our project. Like if in your project, if you want to use any code which is common to the functionality, use that in the util. Then you can use that. Now inside the derived class, main class, program one, I have a main method. Inside main method, I'm creating object of the class G and calling start method. Whenever we call start method, how it is internally executing. By default, if you call Java program one, JVM will allocate some memory. Whenever we call Java, JVM will allocate some memory for executing the program one. Inside the memory, we have a call stack. First main method will execute, default executable method. In main method is executing based on the main thread. Main thread is responsible for executing the main method. The main thread also created by the JVM. Now JVM is created a main thread. Main thread will execute. Main thread will take care of executing the main method. Now inside a main method, I'm creating one more thread. Class E thread object is created. I'm calling start method. Whenever we call start method on any thread, it will allocate, JVM will allocate some other memory for the class C to execute the class C task. Whenever we call start method, it will allocate some memory. Inside the memory, class C task will execute. Start method internally execute the run method of class C. It will execute this. First, it will print from 1 to 5. Multi-threading is, it won't wait for to complete the class C task and it will go for class F task. Just create, whenever it calls start method, it will allocate some memory. It will tell the JVM to execute the class C task. Class C task means start method internally execute the run method. Similarly, class F, it won't wait for class C has to complete the task. It will come out and it will execute the class F. Class F object is created, calling the start method. Just telling to the JVM, take care of executing the class F by allocating some memory. It will continue the execution. Then again, class G. G also allocate some memory for class G and execute the start method. Now here, whenever we call start method, JVM will allocate some memory call stack to execute our class C thread. Each and every thread is allocated some memory in the JVM to execute the thread class. By default, main is a main thread. Main thread is allocating some memory. Till now, we have seen so many examples. In each and every example, main method is there. Main method is a main thread, will take care of executing main method. Inside main method, we are calling test method, test one method, we are calling other methods. Those all methods will go and execute in that stack, main stack. Similarly, I am telling for the other threads also, some call stack is allocated in the JVM. It will take care of executing. It won't wait for main thread has to complete this execution and come back and execute the class E thread. Now the main point is for every thread, call stack is allocated in memory. Till now we have seen for main method execution, some stack is allocated for the main thread execution. Stack is some memory. Now here in this program, we have created 3 thread objects, E, F, G. For these threads also allocated, JVM will allocate 3 call stack memory. For every thread, one JVM will allocate some call stack. So all threads are executing simultaneously, concurrently. Now let's go and run this. Now class E. After that, class F, class G. Let's go and run this again. Now if you see class E, after that class F, it is not the output is not consistent. The output is coming as a inconsistent. The output is mixing together and coming, it is inconsistent. Consistent. When we run the program first time, it will give different output. When we run the program second time, it will give the different output. If we run the program third time, it will give different output again. Now it is calling V 4 times, then F and G. We call the program fourth time. Now this output will become something different. This also gives same, but if you call again, now here if you see, before completing class C, it came to F because call stack is different here. Now here we have to learn one concept, synchronization. Synchronization is very important in multithreading. Everywhere we will get this question in interview. What is synchronization? Then why we need synchronization? See, if multiple threads are accessing same resource, we'll get inconsistent output. Here, class E, class F, class C. These are the three threads. Three threads are accessing the same resource, util class, util.print number. If multiple threads are accessing same resource, we'll get inconsistent output. To avoid inconsistent output, we have to use synchronization. Why to use synchronization? The answer is, if multiple threads are accessing same resource, for example, class C, class F, class G, all threads are accessing resource util print numbers method. If multiple threads are accessing same resource, we'll get inconsistent output. To avoid the inconsistent output, we have to use synchronization. Synchronization is used to avoid inconsistent output when multiple threads are accessing same resource. Now here threads are E, F, G, same resources util. Now how to apply synchronization? See, whenever we have a resource, if you make the common code, the resource function as synchronized, then we are applying the synchronization for the util resource here. If you make the method as a synchronized, so we are making the util is a synchronized method. See, whenever we make the method as a synchronized, we'll get consistent output. Always any number of times if you run. First, it will take the lock of the object util. First, it will complete execution of the thread 1 first. After it is completion of the execution of thread 1, then it will release the lock. Then it will give lock to the second thread. And second thread will take care of executing the synchronized method. After completion of second thread, it will release the lock. Third thread will take the lock of the synchronized object. Then it will continue execution of the synchronized method. Now if we see, first thread, class E thread, will complete execution. Then it will release the lock. The same lock is taken by the F thread. It will complete its execution. Then it will release the lock. Then third thread will take the lock and it will release the lock. Now what is a lock? For every object, we have one object lock. For every object, we have an object lock for synchronized methods. When we need to access that synchronized method, we need object lock to execute that method. Once thread 1 is taking the object lock, thread 2, thread 3 not able to access that method until the thread 1 has to complete the execution of the print numbers method. Thread 1 will release the lock. If execution is completed of print numbers method of thread 1, then it will release the lock. Once it is released the lock, thread 2 or thread 3 can able to take the same lock and it will execute the synchronized method. What is synchronization? To avoid the inconsistency, we are making our resource as thread safe. Basically, whatever methods are normal methods which we are writing, those are not thread safe. What is thread safe? Multiple threads cannot access the same resource because our util class is having a synchronized method. If you want to access the synchronized method, we need object lock. By using object lock, only one thread can able to access the print numbers method. Other threads cannot access until the first thread has to complete execution of print numbers method, then it will release the lock. After it is releasing the lock, other threads have possible to access the print numbers method. That is called thread safe. To make the method as a synchronized, so that methods we can call as a thread safe. Thread safe means multiple threads cannot access the same resource. That is called thread safe. If you are making method as a synchronized, you can call that as a thread safe. The basic method, whatever method we created till now, those are the not thread safe. Now this util class print numbers method is thread safe, synchronized. How to access the thread safe method? To access the thread safe method, we need object lock. For every object, we have one object lock. Only one thread can take the lock, it will execute the print numbers method. Other threads cannot access the print numbers method if it is synchronized. If it is not synchronized, any number of threads can access the print numbers method at a time. Since it is a thread safe, only one thread can able to access this. Now, to avoid consistency, we need synchronization. That is called this one. Applying the method as a synchronized, only one thread can able to access this method. Now here if you see, first E thread accessing the print numbers method, it is completing its execution. Then F thread is able to access. Then G thread is able to access after F thread completion. This is one concept, synchronization. Now here we won't get inconsistent output. If it is not thread safe, Control X. No, this is not thread safe. It will give you inconsistent output. First class E, class F, class G. Again run this. Now class E. Again then class F. Again class E, class F. It is just coming, jumbling one after another. First thread is not completed its execution. Second thread came. Again third thread came. That is called inconsistent output. To avoid this inconsistent output, we have to make our method as a synchronized. Now, how many ways we can apply the synchronization? We can apply synchronization for method level. We can apply synchronization for a piece of code in methods. You can apply synchronization for static methods. If you apply synchronization for static methods, we need class lock. For every class, we have a class lock. By using class lock, it will take care of executing that method. For method level, if it is method is a non-static, then we need object lock. Synchronize means we are making the method as a thread safe. Only one thread can able to access. Now method level we have seen. Static method also, this is a static level. Here we need class lock. Now how to apply for piece of code. I want to apply only for this for loop. This is non-static. This I want to apply synchronization only for block of code. You can use this block synchronization of this. Now creating object to the utility class, then I am calling the print numbers method because it is a non-static. Now this is a for piece of code. If you want to apply, only the system out of internal, we can apply by using synchronized block. This is a synchronized block. By using keyword, simply we can apply for the method level. By using synchronized block, you can apply the thread safe for only this block. Here, if you have some other code, this code is not applicable for the synchronization. This is not synchronized thread safe. This is a thread safe. Now let's run this. After first thread, second thread, then third thread. Now this is synchronization. Let's go and see the next program. This is very important. Now next concept is inter-thread communication. This we can call as a producer and consumer problem. We can call these as two names, inter-thread communication. Now here inside program 2, you can see what we have. I have class sender1. Inside class sender1, I have public void send method, which will take argument as a string type, string message. Here I am just printing the system.println, name of the thread, and printing the message. After printing the message, I am just sleeping for 1000 milliseconds. Inside send method of sender, simply we are printing the name of the thread and sending with the message, whatever message you are sending. Then after that, we are sleeping for 1000 milliseconds. This is sender class. Sender class used for only printing the message. We are printing the name of the thread and send message, what message we are sending. Now, I have class threaded send, extents of thread. Inside class threaded send, I have array of strings. String array message I have in the threaded string, which extends thread class, so we have to override the run method. And I have sender1 as also the parameter in the threaded string. send method. I have two attributes in the threaded send. First one is string array message and sender one. Sender one is having a send method. Now I'm just initializing the both variables in the threaded send method, send constructor. I'm passing a string array and I'm passing the object of sender. I'm initializing in the constructor of the threaded send. Now inside run method, what we are doing? If you want to make any block of the code synchronized, you can make it by using synchronization block. Synchronization block is object level here. This is for send object. For send object, we are making the lock. If you want to access any methods of a sender, we need object lock. Here inside synchronized block, we are just printing the name of the thread is thread.current thread.get name. After printing the name, we are just iterating the loop and printing the all messages which sender is sending. Message is a string array. I am just calling the sender.send method by passing the message. When it is calling sender.send, it will go to send method. It is printing this thread.current thread.get name, sending the message. Now let's go to the program 2. Inside program class 2, we have a main method. Simply we are creating sender object. After creating sender object, we have two string arrays, array 1 and array 2. Both are created and initialized. First array is hi, how are you, where are you? I want to use thread 1 to print this all messages. Hi, how are you, where are you? And after that, we have array 2. Here we have 3 set of other messages. I am good, how about you? I am in Bangalore. See, first sender has to send these 3 messages. Second sender has to send these 3 messages. Second thread. Now I have created 2 objects of a threads. In this first thread, I am passing the array 1 with the sender object. In next sender thread, I am creating array 2. I am passing array 2 and sender object. Now we are just creating object to the thread classes, 2 thread classes, and starting the threads. S1 and S2 start. Now, what is the use of join method? Join method, if you call on any thread, once the execution is completed on the S1 thread, then only remaining portion of the main thread will complete. This one. We have at the end of the main thread. If you're not calling join method, it will continue. All threads will continue execution. We'll get this output as a before only. But if you call join method on all the threads, if all 2 threads execution is completed, then only this will come. That is join method. Now let's explain everything again. This sender class used for only sending the message. Sending message means printing the message and going to the time. This is very simple. And we have a thread. This thread is having 2 attributes. One is message array and sender object. So by using constructor, I'm initializing the variables. This is just initializing variables. In the thread class, if extending thread class, we have to override the run method. Inside run method, we have synchronized block. Inside the block, printing the thread name. After that, iterating the loop and printing the all messages. Message is array. Whatever message we are passing in the here, we are just printing the messages one by one. Let's go and run this. We'll see by seeing the output. Name of the thread is thread 0. First thread is thread 0 is printing all 3 messages. And thread 1. This thread is printing all the message of thread 1, which we are passing here as array 2. And end of the thread. If you're not calling join method, What is the use of join method? We have to prevent the execution of the thread classes. If we call join method, once the on which thread we are calling join method, the thread has to complete execution, then only remaining portion of the current thread will execute. Remaining portion is this one. Once S1 and S2 is completed, then only remaining portion will execute. But if you comment this, if you don't want join, if you don't want to prevent the S1 and S2 execution, simply this will come as a before only. See, end of the main thread came in the starting only because all threads are executing simultaneously. Now here, I call join method because I want to prevent the main thread execution. I want to complete execution of S1 and S2. So I call the join method. No, this is not inter-thread communication. It is not a producer-consumer problem. This is just a synchronization block only. We are just using synchronization block. We are just sending the messages to the thread. All these messages. If you're not using the synchronization block for this, we won't get the output as first thread has to complete first, then second thread has to complete next. This is the one. Thread 0 has to complete first execution, then thread 1 has to execute the next when we use the synchronization. Now I commented the synchronization. Now if you call it, we'll give output as a jumbling. Now 1 is execution, 0 is execution. 1 is executing, 0 is executing. It's not consistent. It's coming as a different output. If you call again, we'll get a different output. Now here if you see 1, 0, 0, 1, 0, 1. This is not consistent. If you want to achieve the consistency, you have to apply the synchronization. This is also example of synchronization. Next concept is inter-thread communication. This is a synchronization. To apply the synchronization, it will get output as a consistent. First, it will get thread 0 has to complete the task, then release the lock. Then thread 1 will take the lock and complete the execution of the thread 1. This is still synchronization only. These two concepts not yet came. It will come in the next program. Now, what is inter-thread communication? What is producer-consumer problem? I have two examples. This one first one. So inside program P, I have main method. Inside main method, I am creating object to the producer consumer. My class name is PC. I create an object to this. What is this class we have to see first? See, if you want to create a class inside the another class, you can create a class. This is called inner class. We have not seen the inner classes till now. We'll explain the inner class in the next coming classes. Now here, we can create a class inside the other class. So that class we can call as the inner class. This is a static inner class because it is public static class PC. Static inner class. Inside a PC, what all are there? Inside producer consumer class. This linked list also we have not seen. Similar to the arrays, if you want to store the list of data, you can use the linked list. Linked list of integer types we are storing inside the linked list. It is similar to arrays, but we have some more advantages. We can see this in the collection API. Now I have variable linked list in the PC class, producer consumer class. And I have taken one more variable into capacity equal to 2. I have one list and capacity equal to 2. Two variables we have. Two are the variables declared and initialized. Now we have two methods. One is produce and consume. What is there inside the produce method? Inside the produce method, int value equal to 0. We have a loop, while loop. It's infinite loop. While true, it is always true. We're not changing this loop. Inside a while loop true, I have synchronization block on the current object. Current object is PC object. Synchronize of this. Inside of synchronize of this, list dot size equal to capacity. Now, similar to the arrays, linked list also having a size. The data of the inside the linked list is equal to capacity. Data equal to 2. We have two elements in the linked list. Then we have to call the wait method. We have to call wait method on the producer consumer object. Then after that I am calling system.data now producer value. If it is not true, we are not calling wait method. We are printing the values. Producer equal to the value 1. Producer equal to value 2. After that, we are just adding the values. Let's start add of value plus this. We are increasing the value. A value equal to 0. 0 means 0 to 1, 1 to 2, something like that. We are just increasing the values. After that, we are calling modify method. Now we are calling the thread.string. Now what we are doing here is inside a producer, we are just adding the values to the list. Just remember that adding the values to the list inside a producer. Inside the